Alright, 4.5, applications in 3 dimensions. Nothing new to learn here, we've really just got to apply our current knowledge to the new information and see how we go. So let's have a look at an example. I'll just work through one example and then hopefully you guys will see how it all works and have the confidence to go and get stuck into it yourselves. So we have a tent pole, 2.1 metres high, secured by ropes in 2 directions. The ropes are held by pegs A and B at angles of 43 and 39 respectively from the horizontal. So from the horizontal up, so angles of elevation there. The line from the base of the pole to peg A is at right angles to the line from the base of the pole to peg B, and you can see there's a right angle on the ground there. Round to 2 decimal places these questions. Find the distance from the base of the tent pole to peg A. So I'm going to do my working over here. I'm going to have A part 1, and let's just draw that triangle. So here's A, this is the pole, and we want to find horizontal distance, so that's distance there, and the height of the pole is 2.1 meters, and the angle 43 degrees. Right angle triangle. Before we can solve these questions, what do we have to do? We need to label our triangle. Hypotenuse from the known angle, this is the opposite side, and that's the adjacent. So I need the opposite and adjacent. Recall from SOHCAHTOA. That we must need opposite and adjacent for this one. So tan, opposite over adjacent. So we go ahead and write out our rule. The tan of theta equals the opposite over the adjacent. Theta is 43 degrees, so we replace theta with that. Opposite side is 2.1 divided by the adjacent. If you do a bit of rearranging here, multiply through by A, and I've got A tan 43 equals 2.1. Now I just need to divide by tan 43 to get A on its own. So A equals 2.1 divided by tan 43, approximately equal to, because we're going to be rounding off a little bit here. And we'll go to our trusty Desmos. And what we're looking for is 2.1 divided by tan of 43, which should still be in degrees, so that should be right, 2.25 meters. That sounds very reasonable. It should be slightly longer than the 2.1 because the angle up the top there is going to be 47, so it's slightly bigger. So the opposite side should be slightly bigger. Sounds spot on to me. You can do the same thing for peg B to find the distance along the ground. Actually, we're going to need to do it anyway for part B, so I guess I'm going to do it with you. So here's peg B. Let's draw the triangle first. This time the angle is 39 degrees, 2.1 meters, and there, and I'm trying to find the distance along the bottom. You can see we've already got the rearranged form over here. So without going through all the steps, you can of course follow all the steps and make sure you do it the same way, but the distance must be 2.1. Instead of dividing by tan 43, we're dividing by tan 39 degrees. What's that going to give us for the distance? 2.59. 2.59 meters. There we go. Again, nothing too hard about that. Find an angle at peg B formed by peg A, peg B, and the base of the pole. So what they're asking us to do here is find this angle in there. I want to do it from that angle. So that's on the flat ground between peg A, peg B, and the pole. We want to know the angle at B. So we write that triangle in a way that, draw that triangle in a way that's a little bit easier for us to cope with. So we have the pole here, and now we know that A and B, there's A, go away, there's B. So we want to figure out what that angle is going to be. Well, I just need to know the two side lengths. This is 2.25 meters. This is 2.59 meters. I want to know the angle there. opposite and adjacent, so we need tan again. The tan of the angle, the opposite side is 2.25 and the adjacent side is 2.59. Theta will be the arctan, the opposite of tan. Remember on your calculator it looks like, I will draw it for you in a second, 2.25, 2.59. Arctan is basically the same as inverse tan function, but that gets a bit confusing because it also looks like a power. So even though that's the button we use, I will continue to encourage you to write arctan, but in the exam it will not make a difference. By the way, what will I get for theta? Let's get into Desmos and find out. So I want arctan, double check what values I was doing, 2.25, 2.25, get back in the right spot, 2.25 divided by 2.59, 40.98 degrees. It is approximately equal to 40.98 degrees. Lastly, find the distance between peg A and peg B. Well, there's two ways you could do it from there. I'm just going to go with Pythagoras. So I'm going to call that distance from A to B. I'm going to square that. That equals the other two sides squared. So 2.25 squared plus 2.59 squared. So the distance AB is going to equal the square root of whatever that side happen to equal. So let's go 2.25 squared plus 2.59 squared, 11.77. Oh, let's just go through all those because I missed it. So square root of 11.7706. No need to really write all that out because I had the room there under the vinculum, so why not? And we do the square root of that and we will get to our answer. I can just go back here and cleverly put brackets around it and but it won't let me do that. Hey, well that's right, I'll trick them then. The power of 0.5, we know our index laws. Same thing, 3.43. 3.43 metres seems reasonable. So we've got it. There you go. I hope that helps. Good luck with those ones. Make sure you draw clear diagrams, label them, work one step at a time and it should be fine. Cheers.